All right, so second video for this section on substitution. And in this one, we're going to be getting into definite integrals. The last one, we were just doing indefinite integrals. And so this one is, these are, I wouldn't say any harder than the other ones that we've done, but you can kind of do them in a little different way, in that we do not need to substitute back in. Once we find the integral with the u, we don't need to put the original variable back in. So let's see what we mean by this. So we have the integral from 0 to 1 of t squared over t cubed plus 1 dt. So like we said in the first video for these, the higher exponent function will be the u, and you take the derivative of t cubed and you get 3t squared, or the t squared is the important part, but you're going down in the exponent, so the higher exponent is going to be the u. And then the rest, just like the earlier ones that we saw, is going to be the red part, or the du part. So similar setup, in fact, same setup as what we would do before. So u is t cubed plus 1. Then du is, take the derivative of this one, 3t squared dt. We have an extra 3 in there because the red is just the t squared dt. So we need to divide both sides by 3. And we get 1/3 du equals t squared dt. And so now we can do our substitution. But before we do that, we can do, now you can do these the way we were doing them before, where we'll just integrate with the u, substitute back in with the t, and then evaluate at the limits. But you can also do it this way. And there are, we may not see any in this class, but there are more complex integrals where it's really difficult to substitute back in. So you may not be able to do that in some examples, although I think you probably could in this class. But this is a good little skill to learn. So, whoops, we're using t, not x. So the integral, the original integral that we're given, t goes from 0 to 1. So t goes from 0 to 1. Now we're substituting in the u, and u is t cubed plus 1. So if t is 0, what is u? U would be 0 cubed plus 1, so u would be 1. If t is 0, u is 0 cubed plus 1, so u is 1. If t is 1, then u is 1 cubed plus 1, so u would be 2. So now when we write this integral, let's write the original one, and then we'll do the substitution. So now we're going to change the limits from 0 to 1. From 0 to 1, we're going to change them to 1 to 2. And so we have the u on the bottom. And then t squared dt is 1/3 du. So let's write this like this. There's 1/3 du. And so now we can integrate this, and then we don't need to substitute back. We can just plug in the limits with the u variable. So the antiderivative of 1 over u is ln of u. So this is just going to be 1/3 ln of u. You put it, should always put it in the absolute values. In this case, it doesn't matter because we're only integrating over positive numbers anyway. Don't need the c because we have a definite integral. And then we'll just plug these in. So we get 1/3 ln of 2 minus 1/3 ln of 0, or ln of 1, which is 0. And that is just 1/3 ln of 2. Like that. Okay, so again, substitution is set up in the same way we were doing the indefinite integrals first video. The only difference is, and you don't have to do this, but the only difference is possibly that you can change the limits of integration from the t variable to the u variable. The way we do that, again, if t is 0, plug in 0 for t and you figure out what u is. Plug in 0, u is 1. Plug in 1, and then u is going to be 2. Now you don't have to do that. You could do it this way we did before, and when you get down here, you would plug in, substitute back in what u is. So this line, you'd write 1/3 ln of t cubed plus 1, and then plug in the original limits. So either way is fine. I think it's a better skill to have to be able to change the limits, because that could help you when you get to more complex problems, possibly in a later class. All right, so another one. And so this one's fairly obvious what is going to be the u and the du. So we don't worry about the outside exponent. The 3 minus 5x is our function that we're looking at. So the u is just going to be 3 minus 5x. So then du is negative 5 dx. The red part is only the dx, so we need to divide by negative 5. So negative 1/5 du equals dx. So now let's do the substitution. All right, first, let's change variables. So the limits are x equals 1 to x equals 2. So now when we plug in 1, we get u is 3 minus 5, so u is going to be negative 2. When we plug in 2, 3 minus 10, so u is negative 7. Now normally, the bottom number goes, or the lower number goes on bottom, the higher number goes on top. But in this case, they're going to be flipped, and it's okay. It doesn't matter in that case. Just keep it corresponding in the way that it is. So let's write the original, and then we'll do the substitution. So we have the integral from negative 2 to negative 7. And on the bottom, 3 minus 5x is u. So on the bottom, we're going to have u squared. And then negative 1/5 du. So let's put the negative 1/5 du. And if you want, you can write this so that we don't have a u in the denominator. So we'll just write negative 1/5 u to the negative 2 du. And so let's integrate. So integrate. So negative 2 plus 1, we'll divide this by negative 1. And so we get 1/5 u to the negative 1 from negative 2 to negative 7. So 1/5, and then we'll kind of factor out the 1/5 and then plug in negative 7 and the negative 2. So negative 7 to the negative 1, that's negative 1/7 minus negative 1/2. And we should get negative 1/14 when we do this. Okay. And then the last example we're going to do, ln of x over x integrated from 1 to e. So this one, and on this one, we don't have exponents, so you can't really go by the higher exponent is going to be the u, and the lower is going to be the du. But you can go from the more complex function to the less. And in this case, ln of x is the more complex function. So that's going to be our u, and then the rest is the du. Now, you got to be aware that dx and x are where they are in the function. So x is in the denominator. You can't just say that the du is x dx, because it's not, because dx is in the numerator, x is in the denominator. So we're not changing those around like we did on this one. We didn't say that it was 1/3 minus 5x. It's just 3 minus 5x. So you got to be conscious of these little parts that may be a little bit confusing. But if you just kind of go with what you know is true, that u is ln of x. Now, what is the derivative? The derivative of u would, or ln of x, would be dx over x, which is what we have right there. And so then we can look at the limits of integration. So x is 1 up to x is e. U is ln of x, so ln of 1 is 0. Ln of e is 1. So now we have the integral from 1 to e, ln of x over x dx. And then the limits go from 0 to 1. When we move to the u, we have a u on top. And then dx over x, so that's just going to be a du. So we have u du. Integrate it with respect to u, we get 1/2 u squared, evaluated from 1 to 0. And we have 1/2 times 1 squared minus 1/2 times 0 squared. And that is just 1/2. All right, so again, these definitely get easier the more you practice them. The main idea is you need to get good at recognizing what is the u, because once you get the u, you just take the easy derivative, and whatever is left has to make up the du. And then you may or may not have to rearrange this du function or equation to get where you need to get or match up with what's in the original integral. All right, but if you have any questions, you are free to email me and I'll answer them as soon as I can.